so then we'll do some more 1.6. So the second page, here are the questions. Number 5 says the cube root of 3x plus 2 equals the cube root of x minus 1. So what do we need to do? Have we isolated a cubed root? Or we've isolated a radical? Yeah, we have a radical on both sides, so it's isolated. So I'm just writing this in between steps so you can see that I'm cubing everything. If you don't want to write this step and you just want to write it here, that's fine. That's what I usually do, but I feel like it's a little nicer to see like this. Okay, so the cube root and the cube cancel each other out. Right? Then what type of an equation do I have?
You put 3 inside 2.
Oh, thank you. Okay, so what type of equation do I have? Linear, right? I have x to the first power. So I'm just solving for x, right? I get everything with an x on one side and everything without an x on the other side. So I'm going to subtract x from both sides, and I have 2. Then I'm going to subtract 2 from both sides, and I get negative 3. So 2x equals negative 3. Okay? So I'm not writing that step anymore where we add and subtract stuff. So now how do I solve for x? Divide everything by 2. I get x equals negative 3 over 2. With these ones, I have to make sure I check my work. So I'm going to check x equals negative 3 over 2. I'm going to plug that back into my original. I have 3 times negative 3 over 2 plus 2 equals the cube root of negative 3 over 2 minus 1. What do you guys think? What do you got? Who's got a calculator? What'd you get, Jen?
They equals each other. I got like a decimal.
It's probably some ugly root.
Yeah, it was like negative 1 point something.
Okay, so let's add fractions. Negative 3 over 2 minus 1 is what? Negative 5 over 2. Am I allowed to have this cube root negative inside the cube root? Yes. You can have it inside a cube root. You cannot have it inside a square root. So I can have a negative inside an odd root, but not an even root. Okay? If you're not sure of that, you can always plug some number into your calculator and see. If it comes back and says error, that's a no. And you said they were equal?
Yeah.
Okay. Did everybody else get that they were equal? All right, so let's do number 6. So are we good with this? So what's the deal with number 6? There's 2 roots, there's 2 radicals, and there's a number. So the first step is we need to isolate one of those roots, whichever one we want. So let's add the square root of x minus 3 to both sides, and I have the square root of x plus 2 equals the square root of x minus 3 plus 2. So now I'm going to square everything. Right? The square root and squared cancel each other out. So on the left, I'm left with x plus 2. And on the right-hand side, what am I left with? What do I need to do? I need to distribute, right? I need to FOIL. This thing squared is that by times itself. So I need to FOIL. So can I just do that, or should I write down an in-between step? So that's FOIL, right? So I FOILed and combined my like terms. Is that okay? Is that okay? Yeah? Do you want me to write down how I got this, or are we good? Okay. I'll write it on the board. So I have the square root of x minus 3 plus 2 times the square root of x minus 3 plus 2. And I'm going to FOIL. So I'm going to do my first times my first, right? Because I have x minus 3 times x, the square root of x minus 3 times the square root of x minus 3. That's the square root of x minus 3 squared. So that gets rid of the radical. So I'm just left with x minus 3 for that first term. And then I do the second, and I have 2 times the square root of x minus 3. And then for my third term, I have plus 2 times the square root of x minus 3. And for my last term, I have 2 times 2, which is 4. Okay? And then I combined these two. I have the same radical, the same stuff under the radical, so I can just add the constants in front. So that's how I got x minus 3 plus 4 times the square root of x minus 3 plus 4. Okay? So here, let me just write that. This is the square root of x minus 3 squared. Okay? Okay, so the issue is now is that I still have a radical, right? I still have a radical. So if I'm trying to solve that, I need to isolate that radical, right? Even in the steps we said, step 3 says solve, but I might need to repeat step 1 and step 2. So that's a situation like this. I need to repeat step 1 and step 2. So I need to isolate the radical again, and then raise both sides to the whatever power. Okay, so let's see what we can do. I'm going to subtract x from both sides, and I have 0x. Then I have negative 3 plus 4 is 1, so I'm going to subtract 1 from both sides. So I get 1 equals 4 times the square root of x minus 3. Right? I subtract x from both sides, I get 0x, and then I have negative 3 plus 4, that's positive 1. So I'm going to subtract 1 from both sides, and I get 1 equals that. Are we good?
You already moved the 2 on the left side? Or is it still there?
This 2?
Yeah.
So I said negative 3 plus 4 is 1. So I subtracted 1 from both sides. Is that okay? Too much? Too fast? Let me... I'll combine my like terms on the right-hand side. And then I'm going to subtract x, subtract 1. And I have 1 equals 4 times the square root of x minus 3. Okay, so do I have my radical isolated? Not quite, right? I have 4 times a radical. So I need to do a little something else. I need to divide both sides by 4. Okay, now do I have my radical isolated? Yes. Once I have my radical isolated, I can raise it to the power that I need. In this situation, what's the power I need to raise it to? Squared, right? Because this is the square root and squared cancel each other out. So on my left-hand side, what do I have? What is it? Good. 1 over 16. So I have the numerator squared and the denominator squared. And then on the right-hand side, the square root and the squared cancel, so I just have x minus 3. I'm going to add 3 to both sides because I have a linear equation, right? So I just solve for x, get everything with an x on one side, everything without an x on the other. So I'm going to add 3 to both sides. What do you guys get?
$49
49 over
over 16.
16. Okay, so again with these, we need to check our work. Check x equals 49 over 16. All right, so I'm going to plug that back into the original. All right, who's got their calculator? What happens on the left? So this is a solution. Okay? So are we good? So these are a bunch of different examples of how to solve radical equations, Maya. So which part do you want me to start from? The top?
Where you're foiling.
Here? Okay, so the steps for solving a radical equation are, first step is isolate the radical. Here we have 2 radicals, so we're going to isolate one of them, whichever one you want. So we isolated the square root of x plus 2. And then we squared both sides to get rid of this radical, right? Once we squared both sides, I got x plus 2, and on the right-hand side, I got this after I FOILed, which I did on the board. I got to this step, and I said, hey, I still have a radical. So again, I need to isolate the radical and raise both sides to the nth power. Okay, so the next couple steps are moving stuff away from the radical to isolate the radical, and I got down here. Once I isolate that radical again, I raise it to the nth power, which meant I squared it. So the square root gets rid of the squared, and I'm left with x minus 3. 1 over 4 squared is 1 over 16. So now here I have a linear equation. To solve a linear equation, I want x equals a number. So I need to get x by itself. So here I added 3 to both sides. And I got x equals 49 over 16. Okay? It's just doing, for this problem, you have to do it twice. That's what's a little tricky. This problem, we also had 2 radicals. Number 5, we had 2 radicals. But because I had just the radicals on both sides, I didn't need to do it twice. Once I cubed it, it canceled out the radicals, and I was fine. Here, once I squared it, I didn't cancel out the radicals, so I need to do it again. Okay? All right. So part B is if I have something of the form x to the m over n equals k. So if m is even, then I end up with plus or minus. If m is odd, then I do not end up with plus or minus. Okay? So m is in the numerator of your power. So let's look at number 7. So see how the steps are the same? It just depends on if m is odd or even. Yeah? Right, if I have x to the m over n equals k, I raise it to the n over m, and that's because of rules of exponents. Once I multiply those exponents, that m over n times n over m equals 1. You just have to remember, though, that if m is even, it's plus or minus. If the numerator is odd, then it's just the same sign. Okay, so let's look at number 7. I have 8x to the 3 over 2 minus 24 equals 0. So again, I need to isolate that power so that I can do all this business here. So isolate that power. I'm going to add 24 to both sides. I get 8x to the 3 over 2 equals 24. Here, what's my m? What's my n? Good. M is the numerator. It's odd. So I'm only going to end up with the same sign. So let me write an additional step. So what power should I be raising this to? 2/3. Good. That's because 3 over 2 times 2 over 3 is 1. Okay, so on the left-hand side, I get 8x, and on the right-hand side, I get what? Is it 16? I got a fraction when I did it, or a decimal when I did it. What'd you get? Something. Yeah, I think I got a decimal when I did it. So you can do 24 to this little caret right here is the power, and then you should put that power in parentheses. So to the 2 divided by 3. Because if I don't put it in parentheses, then I'm saying 24 squared all divided by 3. So it's 8 point something something ugly. So 8.32033 something something. So let me just show you guys. So 24 to the 2 divided by 3. So see how these are different? So make sure you put that power, if that power is a fraction, you have to put that in parentheses, okay? Good? Okay, so now I need to divide both sides by 8. And I get x equals what? What did you get? 1.04004. Is that what everybody else got? Okay, so again, we should check our work. So 8 times 1.04. And so if you have your calculator, do not round this number until the end. Keep this number in your calculator and plug everything back in. So are you getting that it's true? Yes? That's why it's important to not round until the end, because if you put in like 1.04, you're going to get some ugly decimal, and you won't get it right. So this is a solution. This is the only solution, right? All right, can you guys try number 8 by yourself? Bless you. Good? So x equals -1 is the solution. Are we good with this one? It's very, very similar to number 7. Okay, so number 8. I have x minus 1 to the 2 over 3 equals 7 minus x to the 1 over 3. What do you guys think? So the powers are not the same, so I can't really raise that to a power, right, to get rid of it. What could I do? Well, I could raise it to the 3 over 1, or I could raise it to the 3 over 2 to cancel out one of these powers. So if I raise it to the 3, that gets rid of this. If I raise it to the 3 on the left-hand side, then I just have this left-hand side squared, right? If I raise it to the 3 over 2, though, that gets rid of this power. If I raise it to the 3 over 2 here, then I would have this to the 1/2 power, right? Is that right? So then I would have the square root on the right-hand side, and I would still have to square everything, right? So let's raise it to the 3rd so we're not doing an extra step. If you would have raised it to the 2 over 3 and you would have done that, then you could just do the square root stuff. I'm just trying to think ahead without writing to save myself a little bit of work. But if that's what you do, that's totally fine. So I have x minus 1 squared equals 7 minus x. Just from rules of exponents. Use those rules of exponents. Right? I'm multiplying these exponents, and that's what I'm left with. Okay, so now what do I need to do on the left-hand side for the squared? I need to FOIL it, right? So I get x squared minus 2x plus 1 equals 7 minus x. So now what type of an equation do I have? Quadratic. So I need to get it equal to 0 in order to solve. So I'm going to add x over, and I'm going to subtract 7 over. Once I get it equal to 0, then I need to factor. Did I get this right? Some people are looking at it a little funny. So I subtract 7 over, I get -6. I add x over, and I get positive x. Oh, this should be... Is that why you guys are looking at it funny? Okay, so now I'm going to try to FOIL. If I can't FOIL, I can always do the quadratic equation. So what multiplies to -6 and adds to positive 1? Is that good? Yes, it would be. So how does that change what I FOILed? Or how does that change my factors? I need to change the signs, right? So then I get x minus 3 equals 0, x plus 2 equals 0. So I get x equals 3 and x equals -2. So then make sure you check your work. So again, I'm going to finish these notes and do a video for online. And then we'll just stop at section 1.6 for the test. Okay? So I'll do a video. I'll put it online for the rest of this section. This section will be on the test. Monday we'll do review. Wednesday will be the test. Email me if you have any questions. And everybody stay safe.